Hey guys, welcome to another video. It's Roland, your tutor. Today we'll be discussing solving simultaneous equations by graphing. I'm pretty sure you haven't seen this before. It's kind of an unusual topic. So I thought let's tackle this one today. So let's start with an example. Let's look at 4y plus 3x is equal to 100. That's our first equation. Our next equation is 4y minus 19x is equal to 12. Now just remember what I said, graphically is kind of unusual, but at the end of the day, if you look at it, those are both straight lines. They're both equations for straight lines. So what do we do? Our first step is let's write both equations in the form of y is equal to mx plus c. So that's the equation, the general equation for a straight line, and that's why we will be using this sort of structure. So there we have it, y is equal to mx plus c. Just making sure that you remember your c is your y-intercept, your m is your gradient, and y and x are points on the graph. So we start off by writing our equations again. We then manipulate the equations. We separate the terms. We will take, for instance, 3x on the left-hand side, take it across to the right, making sure to change the sign. And what we do next is we isolate the y by dividing everything by 4. So we then have y is equal to minus 3 over 4 times x plus 25, because 100 divided by 4 is 25. Simple and easy. Come, let's move to the next one. Let's not take too much time. Right. So let's look at the next one. We're looking at 4y minus 19x, which is equal to 12. That's our second equation. In other words, it's our second straight line graph. We've now finished our first. We're starting with our second. What do? We isolate our terms. So let's shift that 19 across to the other side. We'll have 12 plus 19x. What do we do next? Obviously, we need to change our signs. We've got negative on the one side. As it crosses over the equals, it now changes to a positive, as I've shown. What we do now is we try and isolate everything. We also write it out nice and neatly. We write it in the form of y is equal to mx plus c. As you can see, 19 would be your gradient. Divide everything by 4, you get 19 over 4x plus 3. So your intercept there would be 3. Your other intercept above would be the c value. Now with those two graphs, or those two equations, we can now start sketching the graph. I've quickly just skipped forward. We've got our set of axes. Let's put a point down. Let's say we're going to be working with this point over here. The point is about 4 and 20. And the reason I've used that point is because of the fact that we've got 19 over 4. And we have 3 as our first y-intercept. So that's just something just to speed things up. We're not doing functions here. We're just solving simultaneous equations by means of using a graph. The next one is this purple line here where we have y is equal to negative 3 over 4x plus 25. Once again, looking at your c value, you then know where your y-intercept is. And that's why I started at 25 on the y-axis. So now that we've got that, we can clearly see that we've got an intersection at a point that looks something like positive 4 and around about 18 or 20. We're not stressing too much about that, but that is essentially how you work. So you'll draw your two graphs where they meet. You then see that where that point is their point of intersection. That'll give you your x and it'll give you your y. So let's look at our nota bene, something of importance. So use the normal graphing methods to draw the y-intercept and the gradient, okay? Now, as I've said before, where the two graphs meet, that is the point of intersection. That then actually essentially is what we are doing. We're just generally not doing it by graphic methods. So when we equate each other and we find the y's and we find the x's, we find essentially a coordinate point. So in this case, we've got 4, okay, I was close. So it's 422. So these are the respective coordinates for the point at which the two graphs meet and intersect. It's very important to realize that this is not very different from how we normally do these sort of problems. So as you can see, we've got 4 over there and around about 22. Relatively accurate if you ask me. Look at that. So generally speaking, when we do our functions, we find that we've got a 4 and a 22. I'm just putting in red so it's easy to see. So yeah, if you'd like to go and check out the notes, just go through to the website at thinkbrainwave.com. You'll find everything there. You'll find these videos and you'll find the notes. There we go, easy game.